Assalamualaikum warahmatullahi wabarakatuh and have a very good day to everyone. Today we will continue our lesson to resolution of forces for physics form 4. And we will discuss the resolution of forces of an object in an inclined plane. So we have an object with mass m here sitting on an inclined plane. So today we need to resolve all the forces which acted on the object. First force is weight, which is always directed towards the center of gravity. And the second force is normal. And normal, remember normal is the force which is perpendicular to the surface of the object. Can you look here that it is a bit different from our previous lesson? Yes, you need to think differently here. Normal force always directed perpendicular to the surface, right? So if the surface is on the ground, but in this case, the object sits on an inclined plane, still the normal force is perpendicular. So can we compare the inclined plane with the plane which is on the ground? It is a bit different, right? So let's continue. So we learned that there are two forces, which is weight and normal force acted on the object, but the weight of force or mg can be resolved into its component. Alright, the first component is the component which is perpendicular to the plane, which is mg cos theta, and then mg also can be resolved to one more component which is parallel to the plane, and it is mg sin theta. Now, mathematically, I will explain further. So we have triangle here and have theta, which is the angle for the plane. And then we have 90 degree, and the angle here will be 90 degree minus theta. And now we have two parallel lines when we applied algebra, and there is a transversal line cutting the parallel line. So we say that there will be alternate interior angle. So the angle here is 90 degree minus theta. So the alternate interior also will be 90 degree theta. So we have the match angle for 90 degree minus theta. Okay, so here is the angle. Next, so we need to find the angle from the force or weight or mg to the other force which is perpendicular to the plane. By applying trigonometry, mg cos theta is the force which is perpendicular component to the surface, and mg sin theta is the force which is parallel to the surface. And for the situation here, we do not consider the frictional force. So without the frictional force, the object will accelerate down the inclined plane. Now there's one problem here that needs to be solved. Figure shows the free body diagram of a block sliding down a smooth inclined plane with angle of 60 degrees. Sketch the component of weight of the block parallel to the inclined plane. Okay, this is the keyword. Okay, component of weight which is parallel to inclined plane. Remember where plane and the component of weight the block which is perpendicular to inclined plane. Right, for the first question, remember parallel component to the weight is mg sin theta and perpendicular component to the weight is mg cos theta, and theta is measured from mg to the force which is perpendicular to the plane. So now, we have an inclined plane with an object, and the angle of the inclined plane is 60 degrees. Now remember, the most important force here is mg, which is weight, and also the other one is normal force. And then we must resolve weight to perpendicular component to the plane, mg cos theta, and parallel component to the plane, which is mg sin theta. Now we find the resultant force. Now we know all the forces acted on the object. For the solution, I suggest you to do it in a table. You write down the forces which acted on the block, on the object. We know that there are only two forces, which is weight and also normal. We consider the first force, which is weight. So in the x component, remember x component is the component which is to the plane. The x component is mg sine theta, and mg is 24 Newton. We substitute theta to 60 degrees, so the answer will be 20.78 Newton. So this is the parallel component, and this one is, and this will be the perpendicular component. So the perpendicular component to the plane is mg cos 60 degree. So we substitute the weight of the object, which is 24 Newton. Consider the direction is negative 12 because we consider that this area is negative y, and this will be positive y. This is positive x, and the other way is negative x. Alright, so we consider all the direction because force is a vector unit. The normal force acted on the object for parallel component, okay, to the plane is nil. There is no component parallel to the plane, but the component of a normal, which is perpendicular to the plane, is 12 Newton. So we sum up all the forces at the parallel component, and it will be 20.78 Newton. And for the perpendicular component to the plane, okay, we have negative 12 and plus 12, so there will be 0 Newton. So the resultant force is 20.78 Newton, and the direction is towards the parallel component, which is down the inclined plane. Alright, that's all for today. See you another time, another day. Bye bye. Assalamualaikum.